Welcome back to Space Waves. I am John Kingston. I'm the editor at large at FreightWaves, and we're going to talk about manufacturing in space. It was interesting in preparing for this session because for so long, anybody who's followed business knows about how much automation has displaced some jobs, some very, in many cases, low-level jobs that didn't get paid a lot, and it turned out to be that a machine could do things better. What we're going to talk about here today is automating around a very expensive job, and that would be human beings in space to manufacture and get done a lot of the work that needs to get done. So with us today is Dr. Yuske Taguchi. He's talking to me from Chiba, Japan. He is the Director of Business Development for Gitai, which is a Japan-based company. And Gitai is targeting the space market and the manufacturing and other functions that need to be done in space to get the job done. So Dr. Taguchi, welcome to Space Waves.
Thank you, John, and thank you for letting me participate in this session today.
So you have some really cool videos on your website showing what robots can do in outer space. I don't know if they were actually recorded in outer space. Maybe they were recorded in some sort of studio, but it was really fascinating to watch. And certainly I'd recommend that anybody go to the Gitai website to see it, showing what these robots might be called upon to do. Just one small thing they might be called upon to do in space. And one of the reasons you want robots is because the cost of a person in outer space at the International Space Station or somewhere else is extremely expensive and seems ripe for automation, but it's a massive challenge. Why don't you talk about Gitai's founding and how it started out with maybe not necessarily targeting outer space, but certainly is looking at that now.
Thank you, John. And yes, if anyone has a chance to look at our website, I really recommend it. And we have our YouTube channel too with lots of cool videos. Unfortunately, not recorded in space yet, but we will be planning to do that next year, as early as next summer. And our founder, Sho Nakanose, when he founded our company 5 years ago, he didn't exactly have in mind to develop robots for space only. But when he looked into the market to see where it would be feasible to build a few $100,000 robot to do tasks, replacing a person who's working for like $15 an hour with a robot that costs about several $100,000, it's probably going to take about 100 years to make it a feasible commercial activity. But if you look into space, it costs just so much, even just to get a person up there. It used to be about $70 million per person riding on the Soyuz Russian vehicle. And of course, Elon Musk comes with SpaceX, and they reduced the price considerably, but it still costs about $50 million. So it's not just a trip you can take over the weekend. And above that, it even takes tens of thousands of dollars to have one person just living in space. You have to provide water, resupplies, food, clothing. You need lots of resupplies, and you need spacecraft to bring those supplies up to the station. So with in-space manufacturing, building things and manufacturing things in space in mind as of one of the futures, if we keep on relying on people to do the job, it just costs so much to manufacture anything. So that's where we come in, and we try to provide robots to do take on the tasks, and to provide a more cheaper and safer means of conducting tasks in space.
Is it too early to ask what kind of things you might manufacture, or is manufacturing, when you use that term, is that just a broad-based word to cover really any kind of functional activity, whether it's changing a screw or something far more complex?
Of course, we'll start off with supporting the astronauts with their daily chores inside or outside the space station. But in terms of manufacturing, what the industry sees right now is one of the big things is, for example, fiber optic cables. There's a cable called Z-band. They say that if you manufacture it in zero gravity, it enhances the capability that it can transfer information on a cable. And also, one of the things that the industry sees is making medications in space, especially those that can only be reproduced in zero gravity.
So you're talking about applications that will be manufactured in space and then brought back to Earth for use down here.
Exactly. But they don't always have to be brought back down to the Earth for sales. We could also maybe manufacture satellites in space. Because, for example, when you launch a satellite on a rocket, you have to make it rigid and sturdy enough so that it can withstand the harsh launch environment. Lots of heavy shaking, the sound is extreme. But if you think about the lifetime of the satellite, you build it to last, for example, one satellite, you wanted to do Earth observations for 10 years. But you do have to make it so it's strong enough that it can withstand the first 8 minutes of launch. But that sturdiness, that rigidity is not necessary when you're in space. So if you can reduce that extra hard work that you have to build a satellite to make it strong enough to withstand the launch environment, you just remove all that if you can build a satellite in space with no launch.
Now, who do you see as the ultimate customers for this? Would they tend to be a NASA, a government agency, or like I know you can talk a little bit later about your association with JAXA, or is it going to be a private entity like a SpaceX, or what kind of combination of the two?
Well, unfortunately, in the industry, there's still more sovereign or agency activities going on. So our first customers will be the agencies like NASA, JAXA, ESA, but eventually there'll be more and more as people see that it doesn't cost that much to have activities done in space. There'll be more commercial activities going on. So it'll be, of course, beginning with the commercial space entities like, of course, SpaceX, NanoRacks, Axiom Space, but eventually I think the market will grow bigger and bigger, and we'll have more participation in the space industry from non-traditional space companies.
Everything seems so theoretical, but the reality is that but I know that you've got a trial test with JAXA, which is the Japan Space Agency, sometime next year. So this is going to be real. Can you talk about that?
Yes, well, actually, this opportunity that we are going to have is not through JAXA, but actually through NASA. And it'll be brokered by a company called NanoRacks. They're the first company in the world to commercialize space. But they will be launching their own commercial airlock, a special room that connects the inside of the station to the outside. We will have our first in-space demonstration of our robot in that room. It's called the Bishop, and we're scheduled to launch hopefully next summer.
So the Bishop goes up today, and then your demonstration goes up over the summer.
Exactly.
And in your demonstration of your robot, what will it do?
Of course, we want to demonstrate how capable or how dexterous our robot is. So we have two experiments in plan. One is to demonstrate that our robot is capable of assisting the astronauts with their daily chores. So one thing we will do, something called IVA, is short for intravehicular activity inside a vehicle. So it'll be like pushing buttons, turning knobs, pulling in and out cables, typical chores that the astronauts do every day inside the station. And on the other side, our second experiment, we want to show the industry that our robot is capable of doing things even outside the station. Unfortunately, we're not going to have our experiment outside this time, but activities that would be conducted outside. And one of them will be something called in-space assembly. And we will put together a structure and add like panels to it, representing sort of like a huge solar panel or antenna.
Well, it's exciting times. Now, of course, one thing we always ask about here on our various waves presentation is funding, because a lot of the more interesting ventures out there are funded by some kind of private capital or private equity. This is a kind of business that seems, really exciting, but for the future, not the kind of thing that looks like it's going to be generating recurring revenue for any time real soon. So, what kind of time frame do your investors have? Presumably, they went in for the long haul.
They sure did. And they have much confidence in our company that we'll be able to do what we're telling them. Up to date, we've collected about 5.5 million US dollars as of June 2019. And we do actually have some revenue from other space companies, but they're not recurring yet. We don't have a surplus yet, but we are planning to have our first recurring revenue by 2023.
And what would that be? What kind of space directed operation would be able to provide recurring revenue in just a mere 2 to 3 years?
Revenue that we're looking for is something related to what I mentioned before, in-space assembly, or in a more larger sense, it's called OSAM. It's short for on-orbit servicing, assembly, and manufacturing. So anything that's manufactured or assembled in space, that would be one of the first big revenues that we were looking forward to.
Right. And the kind of applications, I guess, that would come out of some of these first manufacturing processes would be really high quality things. I mean, you're not going to put these kind of fiber optics just running from home to home. There must be some kind of demand for, I'll call it super duper fiber optics made in space, that you can meet that need. And that must carry a fairly hefty price tag.
Yes. Actually, I'm not too familiar with how much these things cost, but they're saying that it's feasible to manufacture it in space and bring it back down and sell it on Earth, that so much that it could provide such enhanced capabilities than what you can use on Earth, what you can manufacture on Earth.
On your website, we talked here about the International Space Station. That's going to be your first demonstration project, but you've got a whole scenario of possible usages for your robotics, including base stations on the moon or base stations on Mars. Is the idea here that your robotics will be so adaptable that you can just simply, I won't say simply because none of this is going to be simple, but that take that and scale it into other uses, whether it be a base station or some kind of other international space station?
Yes, well, actually, we're working on a couple sides of building our robot. One is a multi-purpose dexterous robot that can do many tasks, multiple tasks in space, and that one we actually use it more with remote control. So there's an operator behind that robot actually controlling the robot. But on the other end, we're also developing a robot that's more special purpose and with more autonomy. So unfortunately, people have this crazy idea. Well, I won't say crazy, but expectations that having AI or deep learning on a robot it makes the robot can do almost anything possible. But in reality, the extent that the robot can do is probably play chess. So, the technology is not there yet. Yeah. So just having a robot working autonomously, it actually reduces what it can actually do. So that's where we have human cognizance, human recognition behind the robot, so it can enhance the capabilities of the robot. Because, for example, if you send a robot to Mars for the first time, you could teach it to understand a few things, but when it encounters something for the first time, the robot won't be able to understand what it's seeing. It has no idea. And then all of a sudden, it can't do anything anymore because it doesn't know what it's looking at. So in such a case where if you have a person telling the robot, this is a rock, please hold on to it and lift it up, all of a sudden your robot is capable of doing that. And so that's where we always have in mind where there's a mixture of autonomy and human recognition behind it, and it's called supervised autonomy these days.
So let me ask you whether have you developed any robotics where you found that actually you're going to be able to apply them here on Earth? I mean, we talked about manufacturing things out there to be brought back, but are you also finding that is there any possibility of taking your business and scaling into sort of more terrestrial robotics?
Actually, we always had that in mind, but because it wouldn't be a feasible commercial activity to build robots starting for terrestrial applications, we started off in space. But we always have in mind that we want to put our robots into applications back down on Earth. And we already have captured some interest from some industries, like, of course, decommissioning nuclear power plants. That's a big thing in Japan. And also for maybe deep sea excavations, or any environment that it would normally be extremely dangerous or almost impossible for people to go or do.
Okay, beyond your company, what is the pace of change in robotics today? Is this an industry that even 6 months later is almost unrecognizable because of the gains they're making, or is it maybe moving a little slower than you would have expected?
The public expectations are very high, actually, especially in Japan, because the culture, we're very used to having the idea of having robots helping people or in our everyday lives. So people in Japan, when we tell them that we're making robots, they say, "Oh, cool! Can it do this? Can it do this?" But of course, unfortunately, it can hardly do any of that. But actually, development for robots, there was a high expectation one time when AI and deep learning came out, and there was public recognition that robots will be able to do anything, and people will be threatened by Terminator soon. But and actually, I get that question very often at customs. I tell them I work for a robot company. They tell me, "Oh, when is the Terminator coming?" I tell them, "Don't worry, not at least for our lifetime, because there's still so much development that's necessary to have technology that advanced."
Wish we had a little more time, but we're going to have to wrap that up. I do want to turn it over to Dr. Taguchi one last time. What's the main thing we should be looking at Gitai?
Well, this coming year, we're going to have lots of progress coming, and especially starting off with our experiment on the ISS next year. So if you could tune in or keep an eye out on what's happening at Gitai, if you could check our website at Gitai.tech, Gitai.tech. There we'll be posting our updates and videos of our company or of our robot. So if you could tune in, that would be great.
Yeah, do go there and just watch the robot videos for now. That you can do right now. That's very fascinating. And I do want to thank Dr. Yuske Taguchi from Gitai for joining us here today on FreightWaves. I've been very happy to host this conversation. I'm John Kingston, the editor-at-large of FreightWaves. Stick around for more with FreightWaves.
Thank you, everyone. Thank you, John.